Okay, so we have just seen that, just 1 minute. We have seen that from here that our previous model had no arch effect, but there is serial correlations. Okay, now we shall develop another model that is under student t error distributions. So here we shall be using student t error distributions, right? That we shall be developing now. Student t error distributions, and we shall develop a model using student t error distributions. Okay, other thing will remain unchanged. Okay, I go to estimate. You can see other things all are remain unchanged. So here is the thing, IBR is the dependent variable, IBR, C and PBR. So this is remain unchanged, and here is BSR and BBR all remain unchanged, and arch and garch also 1 1, that also remain unchanged. Only and also arch M standard deviation, that will also remain unchanged, but I shall bring a change here, error distribution, right? Here I shall be doing some changes. Suppose here I choose student t error distributions. Okay, then what happens? And the sample size I remain unchanged, right? Okay, now I make it zoom. And then what I can show you the whole things. I just make it zoom so that you can see better. Okay, this is the models, right? You can see it is the main model, right? Right, IBR, C, PBR, and arch M, right? I put it standard deviation, and here in the variance model I put arch 1 and garch 1, that means garch 1 1 model. Then here I put the variance regressor, I put here as before BSR and BBR, but here only I have brought a change. Error distribution, I put here student t, but last time I put student with fixed degree of freedom, but now I put student t to compare between the two models. And the sample size is I put 300 as before. So we can run this model now. Okay, so I press OK, run the models. It is coming up. It's coming up gradually. Okay, come. Okay, the outcome has come up as before. IBR is the dependent variable, that is the garch volatility of the return of Indian bond return, and here I use student t distributions, right? And here you can see the first one is the mean model, and here you can see it is the what is this one? Square root of this one, standard deviation of the volatility of the Indian bond return, right? Standard deviation of the Indian bond return, meaning that risk of the Indian bond return. Okay, the sign is positive, the coefficient is positive, that is following our target, that is following the, so it should be positive, right, all the time, but the probability, it is not significant. It is not significant under student t distribution, right? Student t distribution, it is not significant. That means there is no risk, right? No risk. Risk is not significant, meaning that the standard deviation is not significant, meaning that the risk of the return is not significant to explain the volatility of the Indian bond return. And what about Garch model? You can see from here Garch, right? This is the Garch model, C4, C5, C6, C7, C8, right? So this is the Garch model. So what is called Garch here? Garch is the volatility of the Indian bond return. So that is the dependent variable, which is Garch, volatility of the Indian bond return. And here we can see the Garch model here, the variance equation, right? We can see from here, and the dependent variable of the variance model is the volatility of the Indian bond return, right? So here you can see what is receipt. Receipt means arch effect, and what is this? Garch effect. So is this two are significant? Arch significant. That means arch significant means previous periods, previous days return information about the Indian bond return is significant. That means previous days volatility of the Indian bond return is significant, meaning that previous days volatility can affect Indian bond return volatility. So that is internal causes. Internal causes can affect, internal information can affect Indian bond return volatility. But what about Garch effect? Is it significant? No, it is not significant because the p-value is more than 5%. So only the arch effect is significant. That means internal information, previous days internal information can affect Indian bond return volatility. Okay, then what about external causes such as BSR? What is BSR? Bangladesh stock return. Is it significant? No, because the p-value is more than 5%. So meaning that Bangladesh stock return cannot influence the volatility of the Indian bond return. What about BBR, Bangladesh bond return? Is it significant? It is also not, because p-value is 6.9%, which is more than 5%. Meaning that external volatility such as BSR and BBR cannot influence the volatility of the Indian bond return. So that is the decision of this model. Only the arch, which is internal volatility, can affect the volatility of the Indian bond return. Okay, then what about the Akaika value? Akaika value is 7.22. and Schwartz value is 7.11. Okay, I write it down here. So Akaike value is 7.22 and Schwartz value is minus 7.11. Okay, and what is the guideline? The guideline is lower the value, better the models. Okay, so last time we did also Akaike and Schwartz value. So last time you can check from here, I go up. Last time you can see we did Akaike and Schwartz value. It was something like this, and that was under student with fixed degree of freedom. So under that, Akaike value was minus 7.36 and Schwartz value is minus 7.26. And now we are doing under student t error distribution. Akaike is minus 7.22 and Schwartz is minus 7.11. Okay, now the question is that between these two, which one is the lower? So between these two, the lower one is which one is the lower one? That you have to find out. The lower one is this one. The previous one is lower. That means this one, right, is smaller, right? The previous one is smaller, right, than this one, right? So meaning that previous model, which is under student with fixed degree of freedom, is better compared to this model, meaning that student with t error distribution model. So the previous one is better because previous one Akaike and Schwartz is smaller, right, is smaller, so it is better. Okay, now the thing is that okay, what about this model? We check the diagnostic of this model, diagnostic checking, meaning that whether this model has serial correlations or the arch effect, right? We can check. Okay, first we check whether this model has arch effect or not. After running it, I go to view, residual diagnostic, then I choose the arch LM test right here, then arch model, right, number of lags 1, I click here 1. Okay, arch test, you can see arch test, observed R squared, p value is 98.93%, which is more than 5%, so we cannot reject null hypothesis. What is the null hypothesis? There is no arch effect and we cannot reject it. So we are happy about it, that after estimating arch model, there is no arch effect. We are happy about it. And then check serial correlations. I go to view, diagnostic, correlogram, square residuals. I choose 36. Okay. Okay, you can see from here, you can see the p value is getting smaller, right? P value is getting smaller. So meaning that there is serial correlations. You can see here Q statistics and probability value, right? So you can see here, right? So we can reject the null. What is the null hypothesis? There is no serial correlations. And here the p-value is less than 5%. So we can reject the null hypothesis, meaning that there is serial correlations. So we are not happy about the model because there is serial correlations. So that is the weakness of the model. And previous model also had serial correlations. So that model is not good also. Okay, but between these two models, suppose we say that serial correlation is not a problem, but it is a real problem. We cannot deny it. But suppose we assume that it is not a problem, then out of these two models, which one is better? Out of these two models, the model which has a lower AIC or Schwartz, that is better model, meaning that Akaika and Schwartz, right? The previous model that had lower Akaika and Schwartz, so that was a better model, right? Because lowered the value, better the model. Lowered the Akaike and Schwartz, so better the model. So previous model is better than this model that we have developed here. Okay, then what else? I think everything is done. Everything is done, so we are settled so far. Okay, it is done. Thank you very much for being with me for a while. So these are the terms of uses of this model.